Alright guys, let's talk about force vectors and their vector components. In a two-dimensional coordinate system, any vector can be broken down into its x and y components. Okay, so what do I mean by that? So if we are given any vector, let's just draw a simple force vector like this, and we're going to call that F. Okay, this guy is F. F has a x component and a y component, okay? So F has got this y component here, call that Fy, and then it's also got an x component here. I'm going to call that Fx, okay? And the way we solve for these is we actually take those components along with F and we create a triangle. So you can either take f of x and move it up here to represent that triangle, or you can move Fy and put it over here. Okay? So for the most part, what I like to do, so you've got F like this. I like to draw Fx in the same spot, that, and then I put Fy here, okay? So you get a vector, arrowhead up, arrowhead should meet with this guy, okay? Now that we've got a triangle set up, we can call F our hypotenuse. Okay, we are interested in this angle here. We'll call that angle theta. It's theta degrees. That makes Fx our adjacent side, and that makes Fy our opposite side. Okay, those are going to be important because we can use all of that terminology now along with our trigonometric functions. So our first one, if you remember, is sine of theta degrees. Okay, sine of theta is equal to opposite over your hypotenuse. Okay, so in our case, that's going to be equal to Fy over F. Okay, then if you do some rearranging and simplification, we know that Fy is going to be equal to F times sine theta. Okay, so that's one important equation that we can use, knowing this relationship of our triangle here. The next one is going to be cosine of theta is equal to our adjacent side over our hypotenuse, which in our case is Fx over F. So if we rearrange that guy, we get F of x, or F in the x component of F, is equal to our force times cosine theta. Okay, then we've got one more. If you remember, we also have something called tangent, or tan theta. Okay, that's going to be equal to our opposite side over our adjacent side. So for us, it's going to be equal to Fy over Fx. So you can split this guy up two ways. You can either say Fy is equal to Fx tangent theta, or you can say Fx is equal to Fy times tangent theta. Okay? So let's use what we just learned to solve a quick example. So We're going to use example. We're going to use f again, just so like it's nice and easy. So f is a vector that exists in our regular coordinate plane here. Okay, so we get y and x, like that. See if we can get focused a little bit better here. Maybe not. There we go, that's a bit better. So, f is just a vector that exists in space here. So we're going to call this guy f. We know that f is equal to 10. Okay? And we know that when we put our x and y components in, they look something like that. And we know that f is rotated counterclockwise 60 degrees from the x-axis. Okay? So if you're given magnitude and direction, you can solve for the components. So using what we just did previously, we know that fx is going to be equal to f times the cosine theta. Okay? So in this problem, f is equal to 10, and our cosine is going to be 60 degrees. Okay? So we can grab our calculators here, like this. We know that f is 10. I'm going to multiply that. Let's see if you can see my calculator here. Move it over there. Cool. 10 times cosine. Make sure that you're in degrees. 60. Okay? Boom. F of x is going to be equal to 5. Alright, so same thing for fy here. We've got f times sine theta is equal to 10, because f is 10, times sine 60. Okay? So if we use our calculator again here, we type in 10 times sine 60 degrees, we'll get 8.66. So fy is equal to 8.66. All right. So, but what if I want to check my answer? What if I want to do my due diligence and make sure that I've done this problem correctly? Well, we have a few ways that we can go about that now. But if I know the x component of a right triangle and the y component of a right triangle, I can solve for the hypotenuse using something called the Pythagorean theorem, which says that a squared plus b squared equals c squared. Okay, c squared in this case is your hypotenuse. 10 squared is 100. So we need to know if 5 squared plus 8.66 squared is equal to 100. So let's look. 5 squared plus 8.66 squared. Enter. 99.9956. So we got 99.9956 is equal to 100. That's pretty close. Okay, remember we did some rounding for f of y, so it makes sense that we're just a little bit off, but it looks like we've gone through and gotten the correct answer. Okay, so this was just a quick introduction on how you could solve for the x and y components of a vector. In the next video, we're going to talk about vectors a little bit more, and then hopefully get into their resultant forces.